Integrated Math 2. This is the solutions for your assignment. It's actually 5.05 and 5.06. It's trig equations. It includes the laws of cosines and sines. So I'll do most of these, maybe all of them. Let's see how it goes here. Okay, so the first 5 or 7 minutes, I'm going to do just a quick review of the unit circle as I did in class. Be sure you remember the concepts of the unit circle. Okay, so here is the unit circle, and this relates to sines and cosines. We started off trigonometry with relating sine and cosine to a triangle. So we'll use 30 degrees as our example angle here. So what I'm going to do is create a triangle right there, and we don't need this number, we don't need that, right there. So this is 30 degrees. Really, actually, the angle here is 30 degrees. Okay, so if this is 30 degrees, then this side, the longest side, is the hypotenuse. And with a unit circle, again, let me get rid of the things I don't need here. The hypotenuse is the longest side, and that equals 1. That's what unit circle means. It means it has a radius of 1. So that's 1 for all of these lines coming out like this. Okay, then we have the opposite side over here. And this side is called the adjacent, ADJ. That's ADJ. That's the adjacent, meaning it's next to the angle. So the angle, the side next to it is the adjacent. The other side next to it is the hypotenuse. That's the longest side always. And then the side across the triangle is the opposite. So what these pairs here are saying is that this side is 1/2 and this side is square root of 3 over 2. On your calculator that would be 0.866, but we don't ever call it that. It's square root of 3 over 2 and 1/2. If you do the Pythagorean Theorem, square root of 3 over 2 squared plus 1/2 squared equals 1 squared. So it obeys the Pythagorean Theorem, those sides. Now, a couple definitions: that a sine is the opposite over the hypotenuse. So that means we would take this side, which is, let's write it down here, it's 1/2. Scratch that because I don't need that either. And let's take this side, which equals square root of 3 over 2. That's this side right here. So the sine is opposite over hypotenuse. So let's write that right here. That would be sine equals opposite 1/2 over hypotenuse, which is 1. Well, 1/2 over 1 is simply 1/2, so that equals 1/2. That means this number right here, it's the opposite, it's the 1/2, but it's also the sine. So this is sine right here. And that's this number right there. Okay, and then if we take the adjacent, the cosine is the adjacent over the hypotenuse, so that would be square root of 3 over 2 over 1. So cosine, I'll write that down here, equals square root of 3 over 2 over 1. So that's the adjacent side, that's the hypotenuse. Well, of course, that'll just simply equal square root of 3 over 2. That means that this number is the cosine. Okay, so that represents the cosine, that represents the sine. All right, and the same would be true of any of the other angles as you go around here. Okay, so just kind of a refresher on all of that as we go into this assignment. Okay, so for this assignment, there's some new equations to deal with. This is an important trigonometric identity, but it doesn't come into play here, and but it simply says, it's simply the Pythagorean Theorem. It says that sine squared plus cosine squared equals 1. Why is that? Well, remember we said that this number is the cosine. So if you take that number squared you end up with 3 over 4. That number is the sine. If you square that number, you end up with 1 over 4. 1 over 4 plus 3 over 4 equals 4 over 4, which is the hypotenuse. Okay? So that's the nature of that. But we're not really going to use that in this assignment. These equations down here are the law of sines and cosines. And they're significant because what they can do is tell you the sides or the angles on any triangle, not just a right triangle. Up until now, it's had to be a right triangle. That's a triangle with a 90-degree angle in it, at least exactly one 90-degree angle in it, okay? That's a right triangle. This can be used, we'll just go ahead and write that. It can be used for any triangle, not just a right triangle. And that's all these rules over here. Okay, you can see that these look a little simpler, but when you explain them, you'll see they're a little simpler than these. So if you can use these, use these. Sometimes you have to use the law of cosines. Anyway, we'll see problems with examples of both. Okay, so let's get going on this. What this assignment's going to do is it's going to combine algebra that we've done in the last 2 to 3 months with trigonometry that we've been doing in this unit. Okay, so what you're asked to do is solve for theta. What is theta? What is the angle that this equation is referring to? Alright, so I'm going to show you the concept of using a substitute variable. Sometimes it's called a dummy variable. Dummy variable really has a specific meaning in statistics, but sometimes it's just used to mean a substitute variable. So what we're going to say is that x equals sine theta. You can do this problem without doing this, but I just want to demonstrate it on a simple problem. So wherever I see sine theta, I'm going to put an x and then do my algebra, and then I'm going to resubstitute the sine theta in for that, okay? Alright, so here we go. So if I substitute that x equals sine theta in this equation, I end up with 2x equals -1. So now it looks like an algebra equation, alright? So what I'm going to do is divide both sides by 2, and I have x equals -1/2. Now I'll come over here and resubstitute sine theta back in for x and do the trigonometry part of the problem. That was the algebra part. Alright, so we have to use the inverse sine function to get, whenever you have your angle wrapped up inside of a sine, you have to unwind it. You have to get it out of there. And the way you do that is with the inverse sine function. And the inverse sine function can either be written like this, okay, so arc sine, anything you do to one side, you do to the other. Arc sine is the inverse of sine. Remember how a square root is the inverse of a square? If you square a number, if you take a number, square it, and then take the square root of it, it gets you back to that number again. Addition, subtraction is an inverse. If you take a number and add 2 to it, for example, and then subtract 2 from it, you get back to the original number. So it undoes that. So this is going to undo this, which means you simply end up with theta. And then that's going to equal the arc sine of 2. And I'll show you how to do that on the TI calculator. So it's going to be sine, and up above it, it says sine to the -1. So let's go ahead and write that notation as well, just to show it to you. This could have been written as okay, so arc sine and sine to the -1 are the same thing. This one's obviously a little shorter to write, though. So that's what the calculator shows. So you have second, and then I go to sine, push sine, and it gives me sine to the -1. That's what's in light blue right above it there. Okay. Sine to the -1. And now what we want to know is what's the sine to the minus 1 of negative 1/2. 1 divided by 2, that's 1/2. Close the parenthesis, and I push, and I get negative 30 degrees. Okay? So that means theta equals negative 30 degrees. All right, so where is negative 30 degrees? And I'm going to show you all the possible answers for this. There's more than one possible answer and more than one way to write it. So let's just go through all those. So 30 degrees is what we were working with in our example at the beginning. If you go from here up to here, that's 30 degrees. Negative 30 is going backwards. It's going down to this angle right here. So this answer could be written as negative 30, or if you went in the positive direction, it would be 330, positive 330, going all the way around to there. Or, if you express it in radians, it's 11 pi over 6. Okay, so that's that answer. However, there's more than one answer to this. Where else is the sine of theta negative 1/2? So remember what we said. The second number in these pairs is a sine. So for example, the sine of 30 degrees is 1/2. The sine of 45 is this number, it's square root of 2 over 2. The sine of 60 degrees is square root of 3 over 2, and so forth. So you'll notice you see the negative 1/2 right here for this angle that we just identified. It's negative 1/2. But where else is it negative 1/2? And if you look around, you'll see it's also negative 1/2 right here. Why is that? Because to get down from here to here, you'd have to go down negative 1/2. Negative 1/2. To get down here. But also to get from here down to here, it's the same thing. That would be negative 1/2. 1 over 2. Okay, right there. So it's also 210 degrees. You don't have to give the negative angle of that, just give the positive 210. So the answer would also be 210. Or if you're going to express it in radians, it's 7 pi over 6. So you should be able to identify all of those different ways. Generally, even though this is the one your calculator gave you, that's not the one they would give you on a test. It would be the positive angle or the radians. Here, the positive angle or the radians. They'll generally not give you a negative angle as an answer on the test, even though that's what my calculator gave me there. Okay? All right. So let's go ahead and move on. Okay, again, these pretty much everything you're doing here, problems 1 through 7, involves from algebra and then some trigonometry. So what we want to do is find the angle theta, cosine theta. So first we need to do the algebra so that cosine theta is all by itself on one side of the equal sign. So the only thing we need to do there is add 2 to both sides. So this cancels. This becomes cosine theta equals this. And I broke my rule of not working on my original equation. I should have copied it, but that's already done. Over 2, and then you got to add the 2 to this thing, so that goes on the top, okay? That's not a part of this denominator. It's just 2 sitting out there by itself. So now what we want to do is we need a common denominator for all of these. So there's a 2 here, so we're going to multiply everything by 2. We're going to multiply this by 2, over 2, and we're going to multiply by this by 2. Let me just write by 2. And then, of course, we're going to multiply this by 2. We're multiplying everything by 2 on the top. That makes this cancel. And now this becomes 4, and this becomes 2 cosine. So we're going to go ahead and write 2 cosine theta equals negative 4. And 2 times 2 is 4. So now we've gotten rid of the denominator. So we multiply this by 2. this by 2 and this by 2, and that's what you ended up with there. Okay, so let's simplify. Well, here you have a negative 4 plus 4. Okay, even though they're separated, you can go ahead and add those together. So this cancels with this. So that's what you have there. And now if you divide both sides by 2, I know we just multiplied by 2, but now we're dividing both sides by 2, you get that. These will cancel out. And now we'll come over here to do our trigonometry. Just put a light line right there. Cosine of theta equals okay. So what do you do with this? Well, you could take an inverse cosine, arc cosine of theta equals arc cosine of this, and you'll end up with some angle. So let's go ahead and do that. Let me write that out. This time I'm going to use the -1 designation. There you go. So this undoes this, so that all you have over here is theta. And now you do this on the calculator. Now it's pretty messy, so I'm going to actually show you a different way to do this in a second. But I'm going to show you, it looks kind of messy. What I would do is simply this. I would take the square root of 2. So on this calculator I press second and x squared. And you can see there's a square root sign above that. That's going to give me the square root of 2. Close the parenthesis, hit the equal sign. Now divide that by 2. And it gives you this number, and now you put the negative sign on front of that. So I'm going to make this a negative, and that didn't work. I should have known that. So I'm going to go ahead and I'm just going to put negative, and it's 0.707. I'm going to leave off all the other digits. That's what we had before. Okay, so 0.707. But what I want to do first is take the inverse cosine, because that's what it's telling me to do here. So I have second cosine, there's inverse cosine, of negative, and remember to use this sign for a negative, not the minus sign. That would not work on this calculator. So it's negative 0.707, and I'm going to leave off all those other digits. That's okay. And that gives me 134.99, which really means 135, okay? So that's going to be 135 degrees. And if we come over here, there's 135. Now that's kind of messy to do it on the calculator. You could have done it with the unit circle the way we did the last problem. Because look what we have right here. The cosine, remember the cosine is the first of the two numbers, is negative square root of 2 over 2. That's what we had right there. That's what we had right there. So we could have gotten the 135 that way. We did not need to use the calculator. Okay, but then you have to ask the other question, where else do you have a cosine of negative square root of 2 over 2? And so we come around and we find one right there. The first number is the cosine. It's hard to see the negative signs, but it's negative square root of 2 over 2. So it's also at 225 degrees. And of course, we could have written that in terms of radians, 3 pi over 4. And you never know how a test is going to ask you. So you should be familiar with both. And 3 pi over 4, and this one would have been 5 pi over 4. Okay, and that's the answer. That's what you're looking for. Those angles to do that. Okay. All right. Okay, I tell you what. I'm going to withdraw the requirement of doing these twice. Just go ahead and get them done. Okay. If you do them twice, though, you do them twice because you want to get good at this and you want to understand this. The second time is to just do it without looking at the answer. See if you can cover up the answer and do it. but I'm going to withdraw that requirement. If you did it, I'll give you some extra points. Okay, I'll give you extra 25 points on a 50-point assignment if you do them twice. All right, let's move on to number 3. Start moving a little faster on some of these. Okay, this is simple enough we don't really have to substitute x equals tan theta. It's a simple problem. So what you're going to do is simply just solve for tangent theta. So we're going to say, this time I will write the equation first. You're going to subtract 2 from both sides. And 1 minus 2 is negative 1. So we want to find where tangent theta equals negative 1. So what we need to do is remember what a tangent is. Let's define it. You want to know what this is in terms of sines and cosines. And if we come over here, we see that tangent is the opposite over the adjacent, which means it's the sine over the cosine. We said the opposite is the sine, the adjacent is the cosine. So it's sine over cosine. So we're going to go ahead and write that down here. All right. So where is the sine over the cosine equals 1? It's where the sine and the cosine are both the same number. I'm just going to use a variable here where they're both the same number x, and one of them, doesn't matter which one, has a negative sign in front of it, which makes it negative x over x. Okay, so where would that be on your unit circle? Well, where are the sine and cosine the same number, forgetting about negative sign? Not there, but yeah, right there. If you take square root of 2 over 2, that's the sine, and put it over square root of 2 over 2 there, that's the cosine. That'll be the same number over itself, which is 1. But neither of these has a negative sign, so we have to find where one of these has a negative sign. Exactly one has a negative sign. So we come around and we see, oh, there it is, 135 again. Negative square root of 2 over 2. Okay, so we could write that, if you want to just write that out, negative square root of 2 over 2. I actually did that backwards, that's the cosine. So the cosine in that case was positive. And the sine was the negative square root of 2 over 2. So you have a number over itself, that equals 1, and the negative sign makes it negative. So that would make it negative 1. So the answer to this is that theta, what we should write it properly is that arctangent, you could have done this on a calculator as well. Okay, so this undoes this and makes this theta. And if you did this on a calculator, you would end up with 135 degrees, or the other answer we're about to get. So theta equals 135 degrees, or 3 pi over 4. But there's another place where that happens. I'll write it over here. Where else does that happen? If you come around to here, there you see negative square root of 2 over 2, square root of 2 over 2. The same number over itself with a negative sign, it makes it negative 1. If you put this over this, you get negative 1, just like you did here. Okay, so the other place would be and that would be here at 315 degrees, or 7 pi over 4. And there are both of the possible answers for that problem. Okay, so just review that, practice it on your own for the extra credit points. All right, and that's how you do that. Okay, now we get into ones a little trickier here. This is where you really are going to need the dummy variable here, okay? All right, so you look at this, and first thing you have to understand about this term right here is it's tangent theta squared. It's just that's the way you write it. So let me write that over here. Tangent squared theta, that's squared, equals tangent of theta. Put that in parentheses, now square that. All right, so tangent squared theta equals tangent of theta squared. The reason they don't write the square over here like that is because it would look like theta is being squared, not the tangent of theta is being squared. That would be two totally different numbers. Okay, so what we're going to do now is we're going to set x equals to tangent theta, and now we're going to write this equation. So we have minus 3, negative 3, equals x squared. Okay, so tangent squared theta, if we substitute there, is x squared. Tangent theta squared. This squared. All right, plus 2x, there's your x again, minus 2. So now we're going to rearrange and we're going to turn this into a quadratic. So yeah, we get to do a quadratic from about two months ago or so. Okay, so what we're going to do is add 3 to both sides. This goes away and becomes 0. Negative 2 plus 3 is plus 1. So now you have a quadratic equation right there. And you can solve it with the quadratic formula or by factoring. We're going to use factoring on this one. Okay, so remember what the rules are. We have to find two numbers that multiply to this coefficient 1 times 1. Okay, so first you multiply this times this, they get 1. They have to multiply to 1 and they have to add to this number right here. Hopefully that comes back to you a little bit. Okay, so what two numbers multiply to 1 and add to 2? I think you can all see that one really quickly. It's going to be 1 and 1. So 1 times 1 multiplies to 1, and 1 plus 1 adds to 2. So that means our numbers are 1, x equals, actually it's not x equals, it's 1 and 1. So that means our factor is x plus 1 times x plus 1. And if you FOIL these out, x times x is x squared. X times 1 is x. X times 1 is x. That's 2x. And 1 times 1 is 1. So they get you back to that equation up there. Now what you're doing here is you want to know what the value of x is. So we're going to set this equal to 0. That's actually, the equation is originally set equal to 0. So you have to ask yourself, if either of these goes to 0, then the whole equation will be 0. So what makes this term by itself 0? Well, I'll write it out here. X plus 1 equals 0. Subtract 1 from both sides, and you get x equals negative 1. Okay, so when that's negative 1 plus 1 will make this 0, so the whole equation will go to 0. And of course, this is exactly the same thing, negative 1. So the value of x, there's only one value of x, and that is that x equals negative 1. Okay? So now we've done the algebra. Now we're going to come up here, draw a line here, and we're going to do the trigonometry. So we said that x equals tangent theta. So we're going to plug that back in. Equals negative 1. Well, guess what? We saw this before. Where did we see it? Right here. Right here. This whole problem right here was tangent theta equals negative 1. Tangent theta equals negative 1. So you're going to get the same answers as you got here. All right? Okay, and there are the final answers for this, exactly the same as that one up there. And that's how you do that. So go ahead and get that one written down. Again, first you do the algebra, you got to solve for x. Again, could you have done this without doing the substitution? Yeah, but do you really want to do all this algebra with a tan theta bouncing around in there? That's kind of messy. So, yeah, you don't want to do that. Okay, so you just substitute x, and then it looks like a regular algebra equation. Okay, let's move on to number 5. Okay, this one's very similar. You really should try to see if you can do this one by yourself, all right? So I'm going to turn this into a quadratic. I see that's going to happen because I have a square there and a non-square there, just a sign. So let's do this. So this would become Now we rearrange it so we have a quadratic, and what I'm going to do is add 2x squared here and over on this side. So this goes away. You have a 3 here. Now we need to get this down to a 0, so we subtract 3 from this side and 3 from this side. Four minus 3 is 1. Okay, so now we have another quadratic for us to solve. So let's come over here and try to save some space and do it over here. So they got to multiply to be this number times this number. 2 times 1 is 2. So you have to find two numbers that multiply to 2, and they have to add to that number in the middle, -3. Okay, so let's just start with this. If they multiply to a positive number, they both have to be positive or they both have to be negative. Since they add to a negative number, that means they both have to be negative. So I'm going to start with the smallest negative number, -1. Okay, and -1 times what would give me 2? -1 times -2. So -1 times -2 gives me 2. Now let's see if they add to -3, and they do. -1 plus -2 gives you -3. So these are the two numbers. Now, you remember there was a twist when you had a coefficient in front of the x squared that's not a 1. You take the 2x, not 2x squared, just the 2x, and you put it over this number. Then you take the 2x and you put it over this number. And you reduce. Well, 2x minus 1 can't be reduced, so right away that's one of our factors. And 2x over -2 can be reduced. That cancels with 2 there. So it's x minus, that becomes a 1. So it's x minus 1. And that all equals 0. Remember, the whole equation equals 0, so it still equals 0. Okay, now you have to figure out what x is. Well, in this one, that one's pretty easy. What minus 1 equals 0? That would be 1. So x equals 1. This one, 2 times what number minus 1 would equal 0? So just come and solve that. I'll solve it right here. 2x minus 1 equals 0. I'm going to add 1 to both sides. I don't really have enough room to do it here. You just solve it for x. I'm going to add 1 to both sides. And then I'm going to divide both sides by 2. These cancel, and I have x equals 1/2. So 1/2. So the two possible solutions, remember in quadratics you often have more than one solution or 0 or root. X is going to be 1 or it's going to be 1/2. Okay, so that means we're going to have some options for our answer here. So I'm going to come up here, I'm going to draw a line right here, and I'm going to try to keep. So now we've done a lot of algebra there. So now it's time to do trigonometry. So we said that x equals sine theta. So I have sine theta, I'm going to substitute back sine theta equals x equals 1, so that equals 1. The other one I have is x equals sine theta. So I have sine theta equals this, equals 1/2. Alright, so let's go ahead and take the arc sine of this. So let me do that over here to save some space. So this is I'm going to come over here. So it's sine to the -1 inverse sine of sine theta equals inverse sine of 1. So this becomes simply theta, and this becomes inverse sine of 1. So where basically of theta, I should write theta there. So where is the sine of theta equal 1? At what angle? Okay, and if you look around your unit circle, remember the second number in these pairs is the sine. And the only place that happens where the sine of theta is 1, that second number is the sine, is right here at 90 degrees or pi over 2. So that's your answer for this one. 90 degrees or pi over 2. Okay, and this is theta. Okay, how about this one? I think I have enough space down here. I'm going to take the inverse sine of theta equals inverse sine of 1/2, the other number that we got for x. And I should put theta. So theta equals, write it more cleanly here. Whoops, I don't need to write the theta there. Sorry, I don't need to write the theta there. It's inverse sine of 1/2. Okay, so it's asking theta equals wherever I find a sine of 1/2, that'll be my theta. So where do I see that? Well, right here at 30 degrees. Okay, 30 degrees. The sine of theta is 1/2 right there. The sine of 30 degrees is 1/2. So that means theta equals 30 degrees, but where else? Just go around. Where else do you see a 1/2 where the sine is? Right there. So that would be 150 degrees. Okay, and that could also be pi over 6 or 5 pi over 6. Just getting that straight off of here. Okay, so there's the answer. That's the answer to this problem right here. Okay, a lot of work. Yeah, it was a lot of work. So just remember, kind of break it into the algebra part. That was everything that we did 2 months ago, the type of stuff we did 2 months ago to get x. And then once you have x, you just substitute back in sine. So sine theta equals 1, sine theta equals 1/2, and you figure out what the inverse sines of those two numbers are, and you're done. Okay, let's keep going. 6. Same thing. Well, no, it's not the same thing. Here you simply have a cotangent squared and a cotangent squared, so you can add or subtract those two. First thing, let's define what a cotangent is. And a cotangent is the reciprocal of the tangent. It's, instead of being sine over cosine, that's the tangent, it's cosine over sine. Let's just write that up here. Because ultimately, in many of these problems, we want to get to have everything expressed as cosines and sines, simply because that's what our unit circle does. Everything, all these numbers here are cosines and sines. So we ultimately want to get things to cosines and sines. But for the algebra part, we can just leave it as cotangent, okay? So what we're going to do is I'm going to rewrite the equation. And I'm going to make the substitution right here of x equals cotangent of theta. So we end up with, it's x squared okay, and that's it makes it a little easier to do the algebra. Okay, so here we go. We're going to do algebra. We're going to subtract x squared from both sides. That one goes away. 2x squared minus x squared is x squared. Okay, I'm going to add 3 to both sides. This goes away, so this becomes 0. I'm going to write the answer over here. So 0 equals x squared. And negative 4 plus 3 is negative 1. So x squared minus 1. Alright, if you remember back a couple months, this should look familiar. It's the difference of squares. X squared is a perfect square, 1 is a perfect square. So if you remember, I'll go up to the top and write this, that a squared minus b squared, that's what we have here, a squared minus b squared equals a plus b times a minus b. You may not have remembered that, but I hope it looks familiar now that you see it. Okay, that goes back a couple months. All right, so that means it's going to be that this is going to be equal to x plus 1 times x minus 1. And again, that's going to equal 0. So you can look at this and see this will go to 0 if x equals negative 1. Negative 1 plus 1 would be 0. Or 1. 1 minus 1 would equal 0. Therefore, x equals, let me just write that over here, x equals 1 or negative 1. Okay. All right, so now what we're going to do is come back up here, and let's take those one at a time. So cotangent equals cosine over sine, which equals 1. We'll just start with this one. So where's the cosine over sine equal 1? Well, it's wherever cosine is equal to sine. Okay, whatever cosine is, if sine is the same thing, you divide any number by itself, you get 1. So we have to just go on our unit circle, find a place where cosine and sine are the same. So let's do that here. Start here, let's start moving around. Nope, they're not the same there. Aha, but at 45 degrees, square root of 2 over 2, square root of 2 over 2. So if you put this number over this number, it equals 1. Okay, cosine over sine equals 1. So 45 degrees is one of our answers. Or you can write that as pi over 4. How about the other one? Cotangent equals cosine over sine equals negative 1. So where do we find these two but with a negative sign? We had to do that in an earlier problem. Come around, and there it is right there. There's a negative sign there. It's hard to see. And there's a positive sign there. There's no sign there that's positive. So these two are the same. That's going to be a 1, and the negative sign in front makes it negative 1. So the answer would be 135, 3 pi over 4. Okay, but there's other places where that will happen. Let's keep going. Right down here, you have negative square root of 2 over 2 and negative square root of 2 over 2. So that's the same number over itself. That's 1. And the negative signs, there's 2 negative signs there, so they cancel out. That becomes positive. So that also equals 1. This cosine over sine also equals 1. So that's going to be at 225 or 5 pi over 4. So right here I'm going to write 225 So there's my answers for 1. And for -1, I come around, and there we go again. Square root of 2 over 2, square root of 2 over 2. This one's negative, so that's going to be a -1. When you put one of these over the other, that's going to be a -1. So that's 315. So there's all your answers for that problem. Alright, the next 5 problems are going to be law of sines, cosines. I'm going to leave one of them for you to do on your own. The rest I will do. So let's do the first one here. And you can use the law of sines as long as you have either 2 sides and 1 angle, that is, you know 2 sides and 1 angle, or 2 angles and 1 side. In this case, we have 2 sides and 1 angle. But what are you trying to find out? You're trying to find out all the angles, so we want to know this angle x, we want to know this angle y, we want to know this side over here, okay? So the way you label these, let's look at the law of sines and cosines here. Is if you label an angle B, then side, that's capital B, then side small b is going to be on the opposite side of the triangle. They're opposite of each other. If you label this side A, small a, then angle big A is going to be opposite side. And C is going to be opposite C. It does not matter which side and which angle you label A, B, and C, as long as you keep that relationship. So there's no hypotenuse, in other words, it has to always be called C. That's not true. The other thing I'll say about this is not necessarily drawn to scale. It may look like this side is the longest side, but you may find out it's not. So it's not a mistake. It's just if they don't tell you a triangle or a geometric shape, it has a specific dimensions to it or specific size to it, you can't assume that it is. You can't just assume that this side is longer than this side. So you're going to find out whether it is or not here. So let's go ahead and just label. I'm going to start here and call this angle A. That means the opposite side over here is small a. I'll call this angle B. That means this side over here is small b. And I'll call this angle C. That means that this is small c. So again, whenever you have 2 sides in an angle like this, you can use the law of sines. Here it is right here. So you're going to use any 2 of these, but we've already kind of pre-selected which 2. Which one do we want to use? Well, we know both angle C is 42 and we know side C. So we definitely want to use that one. So it says that the sine of C over C. So we're going to write that. Okay, this is angle C right here. Okay, so that's sine of 42. Let me write it generally first. The sine of C over C. And now I want to find out something, anything that I can figure out. I ultimately want to know all the sides and all the angles. So what's going to be our other one? So we have sine of C. Let me make that look like C. Sine of C over C. That's sine of this over this. Well, we can't use A because we don't know angle A or side A. We need to know at least one of them to use it. So we don't know angle B, but we do know side B. So we're going to say that that equals sine of B over B, because we do know that small b. So we know this, and we know this, and we're trying to find this. And then once we find sine B, we want to find out what B is, what that actual angle number is. Okay, so now we can plug in the numbers. So sine C is sine of 42 over this side C, which is 17, equals sine of B, that's the one we don't know, over side B, which is 22. Okay, so now first let's do the algebra part. We need to solve for this, get this by itself. So what we're going to do is multiply both sides by 22. this cancels with this, and so you have sine of b equals everything that's on the other side. Okay, so I'm going to go to my calculator and I'm going to find the sine of 42. Okay, it gives me that number. Now I'm going to multiply that by 22. Gives me that number. Now I'm going to divide all that by 17. And that gives me that number, 0.08659. Okay, now I want to find out what b is, so I take the arc sine of sine b same thing to the other side. This side simply equals b. That's what that angle is up there. And I do this on the calculator. So I do second sine, gives me arc sine. And then that's 0.8659, close the parenthesis. And that gives me 59.98, which is 60 degrees. When you get one that's that close, it's just 60 degrees. Okay, so b equals 60 degrees. Alright, so that means this angle up here is 60 degrees. Alright, now I can just use the principle that all three sides have to add up to 180. So that means 180 minus this will give me whatever that angle is. Okay, so I'll write that over here. And that equals 78 degrees. Okay, so that means this angle here is 78 degrees. So all three of those add up to 180. Okay, so now we know all the angles. We know these two sides. Just one more to do. We need to figure out what that side is. So we can use the law of sines again. I'll come over here and do that. So we are going to say you could pick either side C or B or C to do this. And I'll go ahead, since we just figured out B, I'll go ahead and use side B. So it's going to be the sine of 60 over 22. Let's write out the general formula. And we're trying to find A. So okay. So we know, so sine of B is sine of 60 over 22 equals sine of A, 78, over A, which is what we're trying to find. Okay, this one, the algebra is a little messier on this one. What you got to do is you got to multiply everything by A. These two cancel. So now you have A times sine 60. So what, I'm going to do this all in one step. I hope I'm not faking you out. I want to get A by itself. So I'm going to divide by sine of 60 and I'm going to multiply by 22 all in one step. That means the 22 is going to come up here and the sine of 60 is going to come down here, and then I'll have A all by itself. Okay, if you need help on that, come to office hours. So I'm going to say A, this side divided by sine of 60 divided by sine of 60. This side multiplied by 22. And then you multiply this side by 22. So the sine 60 and the 22 end up canceling out on this side, and you end up with this. Okay, that's what you end up with. A equals. Okay, if that one again faked you out, then let me know and I'll walk you through step by step, but it's just algebra. Okay, so here we go. So we just go ahead on the calculator. I won't put the calculator in front of the screen. It's sine of 78 equals, gives me a number. I multiply that by 22, equals, gives me a number. I divide that by sine of 60. Equals, and that gives me 24.8. So A equals 24.8. And it's in meters. You're measuring meters. It's a distance right there. Okay, so if I came up here, this is 24.8 meters. So you'll notice that this side is actually longer than this side. So that's just saying that they didn't draw the triangle to scale. It's not a mistake. You just can't assume that this, just because it looks longer, that it is longer, unless they tell you specifically that it is. So you have all the sides and all the angles, so we're done with this problem. Okay, so I'll put it back on screen there. And there you go, so you can get that one down. Okay, do it a second time for extra credit. Try to do it on your own without looking at my answer here. Okay, all right, let's keep going. Okay, this one gives you two angles. Excuse me, it gives you two angles and a side. The other one gave you two sides and an angle. You still use law of sines for this though, okay? And so let's just label. Remember, you get to label however you want to label. So we're going to call this side A, whatever this X is. We'll call this B. We'll call this C. All right, so you got to find the opposite angle. So the angle opposite of that A is this one, so this is angle A. The opposite angle of this C is this one, the 52 degrees. I'll put that in there. And the angle opposite of this B is this one. Okay, and that's, well, I'm going to try to draw it, not draw it right through the 118. That's angle B. Okay, so now you want to start by using C, because you know both C. You know the side C and you know the angle C right there. So we're going to use sine, whatever we're trying to figure out first. We're going to start with sine C over C equals, and now you want to use, let's see, A or B. Well, you don't know the side A and you don't know angle A, so you can't start with that one. You don't know either of those. But B, you know angle B. So we're going to say sine B over B. All right, and now we just plug in the numbers. Sine C, there's C is 52 degrees. And side C is 45 meters. Equals sine B, which is 118. Oop. Over the unknown side B here. Okay, again, what I'm going to have to do is multiply both sides by B. These cancel. So again, I'm going to shortcut this. If this algebra is tricky for you, let me know. I need to get B by itself, so I'm going to divide both sides by sine 52 and multiply both sides by 45. That means these two are going to cancel out on this side, and they're going to appear over here. 45 on the top and sine 52 on the bottom. Okay, and we just run those on the calculator. Sine 118, get that number, now times 45, get that number, and divide by sine of 52. And that gives us 50.4. And that's a distance, that's the length of the side, so it's 50.4 meters. So right there I can write 50.4 meters. Yeah. Okay. So I know this side. I know this side. I can actually go ahead and calculate this angle. I could have done that before I even started the problem. So the angle A equals 180 degrees minus 52 degrees minus 118 degrees. And it's only 10 degrees. It's a pretty small angle. Okay, so that's going to be 10 degrees. So we know all the angles right now, and we know two of the sides. Now we'll use the law of sines to figure out what x is, and that we call that side A. So we're going to use the sine of A over A. This is what we'll use. Equals, this is our unknown. So we can use either of the other two sides. Let's go ahead and use B. So it's going to be the sine of B over B, which we know now, we figured it out, is 50.4. Whoops, I kind of mixed I was going to do sine B over B, but I didn't, so let me go ahead and just change this to sine A, which is sine of 10 degrees. Okay, let me write it up here. Just going to write the general equation that we're using, okay? So there you go. So the only thing of these we don't know is this number right here, okay? Now, again, I'm going to just shortcut the algebra here. I'm going to multiply A by both sides. Okay, so I have A. I have to solve for that A, so I divide both sides by 118, and I multiply both sides by 50.4, and you end up with this. These A's cancel, and you end up with this. Okay, there you go. So now just solve that. Okay, and knock this down. Okay, so sine 10. And it gives you 9.9. So A equals 9.9 meters. That's a distance. So now you've figured out all three sides, or you know all three sides, you figured out two of them, and you know all three angles. So you're done with that problem. Okay, I'm having a little problem with my recording software, so we just finished up with problem number 8. I'm going to go ahead and cut this video now. I will do 9 and 10 for you on another video, and then I will 11 I will leave for you to do on your own. Okay, so I'll go ahead and see you on the next video.